Welcome to the Crazy Hat Chemist. So another video here on kinetics for a fast rate law. Bam! Here we go. We're talking today about a graphical method of determining rate laws. Okay, so a straight line plot yields the correct rate law order. This is a super cool thing. So you can analyze the data, plug it in, and make 3 different graphs, especially if we're talking about 0, first, and second order. Okay, so straight line plots are as follows, and these correspond to the correct order. So if you have concentration versus time, then it is a 0 order rate law if it is a straight line plot. Okay, a straight line plot that is natural log of concentration versus time, that one is first order. A straight line plot that is 1 over concentration versus time is second order. All right, so I'm going to give you 3 of these same examples, and this is the same data on each one of these that is graphed, but with all 3 graphs. Okay, so here's the first one. So the same data. So I've graphed all 3 of them using the same data. That is concentration versus time on the left. In the middle slide there is natural log of concentration versus time. And on the right hand slide is 1 over concentration versus time. So for each one of these, you're going to look at these and which one gives you the straight line plot? Well, it's the middle one, of course, and since that is a straight line plot and it is natural log of concentration versus time, that means that this data is a first order rate law. Let's give you another set. Another set of data. I got concentration versus time on the left. In the middle, I got natural log of concentration versus time. And on the far right, I got 1 over concentration versus time. Which one yields a straight line plot? That is correct, the one on the far left. Since the one on the far left yields a straight line plot and it is the same data, that means that this data is a 0 order rate law. Simple as pie. Okay, the next set of data, again the same set of data, you're going to do 3 different graphs with the same set of data. On the far left is concentration versus time, in the middle is natural log of concentration versus time, and on the far right is 1 over concentration versus time. Which one yields the straight line plot? The one on the far right. And because the one on the far right is 1 over concentration versus time, then you should also see that this is a second order rate law. Okay? The other thing that you have noticed on each of these is I've included the k for the slope, and it is either the k is equal to the slope or the negative of the k is equal to the slope, and then that tells you what the rate constant is from the graphical data as well. Super awesome. We've already discussed the first order rate law. The integrated first order rate law uses the natural log, and that's why the natural log of concentration is a straight line plot. Okay? The integrated second order rate law is 1 over concentration, and the integrated rate law for 0 order is concentration. So I'm going to be discussing that actually in the next lecture here. So make sure that you can either get a set of data and compare different sets to figure out what the order of the reaction is, or you can do different graphs, and from that information you can get the order of the reaction. Okay, I'm the Crazy Hat Chemist, and I got a crazy hat for you here today. It is a chicken. So which came first, the chicken or the egg? I don't know. Give me a thumbs up if you like that video, subscribe to my YouTube channel, and here's a chicken running.